Heuristics are basically hints, different ways, things to look at when you're trying to invent. It makes it easier. And I'll give you an example in a bit. So heuristics aren't aids for discovery. They consist of playgrounds, play tools, play guides, and clings. So here are heuristics. You can also think of them as playgrounds. They consist of playing with space, playing with motion, with time, with structure, with phase, energy fields, and with control mechanisms. We focus on physics because we're focusing on the physical world. We're focused on inventing physical devices, and we're starting with physics, but later on we will expand to more concepts such as chemistry and then business and economics. And here are play tools. These are different ways to play within the playground. You can see here they have things like play with sequence or skip, pull apart, fragment, separate, and you can combine them. So you can play with a phase and then alter it or distort it. So these are ways to think of many ideas very quickly. Now I'll give you an example. This is a simple balance, you can see, and we're going to make it more interesting by using the playground and play tools. We'll play with the structure first. First we'll make it dynamic and also add a tipping point. So you see here now, we add a ball in the middle and it can slide on this teeter-totter thing. So now when it tilts, it adds a tipping point because when it tilts a little bit, it keeps tilting more faster and faster. Also it's dynamic because there's a piece of it that's moving. So this is also the intersection of a playground and a play tool. It's called a cling. This is a way of helping people to remember these different concepts. For example, a starfish, it digests food on the outside of the animal instead of the inside. So that's very unusual, but it's a way to remember this concept of moving something outside of the structure. Also, the information is not presented by the name of the topic of the concept, but rather what it can do for you, for the application. So now I'll give you an example with physics. So this is Pascal's law. Very simply, you can see what it does. Basically, you have a small weight which moves a large distance, so it can move a big weight. Something small can move something large. And on this side, we have basically, you can see what it does. It's color-coded. You can see it can control, lift support, move, multiply force. So if an inventor wanted to do any of these, he would look for this color, he or she. And you can see in red, small force, big impact with a brief description, and also some